Hello Math 7 students, this is simplifying numeric expressions using the order of operations. You have probably heard the order of operations before, just like you've also heard words like expression before. What do they actually mean? The order of operations, you need to understand this, is simply the order that we do operations in an expression. It's the order that we perform them. That specific order can be remembered with the mnemonic GEMMA. A mnemonic is just like a thing that we say that helps us to remember. So the thing that we say is GEMMA. G stands for grouping symbols. Grouping symbols like parentheses, absolute value, long dividing lines, etc. E, which stands for exponents. We haven't seen exponents too much, most recently in this class when we did our circles unit, but we haven't spent a whole lot of math class dealing with exponents, so let's quickly review what exponents are. If I have something like 2 to the 4th power, that's an exponent. You can say 2 exponent 4, but most of the time we say 2 to the 4th power. But what does that really mean? When I have an exponent, what does that mean? So 2 to the 4th, what does that mean, Stephen? There's a better way that we can think of it, but you are right. It is squaring it twice, but there's a better way to think of it. What does it mean, John? We're not timesing the 2 by 4 because if we were timesing the 2 by 4, we would just write 2 times 4, right? So it's not multiplying the 2 by 4. Last one, let's go, Alexis. No, not times 4. It keeps going on forever? Until the 4? What do you mean by that? Emily, finish it up. Yep, timesing 2 by itself. How many times? 4 times. So Alexis, you were close. You were really close. 2 times 2 times 2 times 2. How many times am I multiplying 2 by itself? 4 times. That is what that exponent means, and that is important to understand because you are going to see that again. Let's go back to our circles unit that we just finished. We would have a radius squared. So what did that mean? Radius times radius. How many times? 2 times because the exponent was 2. It was squared. Okay. After G for grouping symbols and E for exponents, then it's M, which reminds us that we need to do multiplication and division. However, something is really important to acknowledge. We do multiplication and division in order from left to right. A reminds us to do addition and subtraction. They happen at the same time, so we do them as they appear in order from left to right. Now, in the conversation that we had before I actually started recording, some students remembered order of operations as PEMDAS. Raise your hand if you have heard of PEMDAS before. Good, now strike it from your memory. Forget about it. Because GEMMA is a way better mnemonic device because it reminds us of all the other grouping symbols besides just parentheses. When we have PEMDAS, remember how that P stood for parentheses? We're not always going to have parentheses, and you will see examples like that later on. For example, you might have, who remembers what this symbol is going back several units? What is this symbol? Good, a couple of you remember. Seth. What is this symbol called? Orion, do you want to help him out? Nope, it doesn't mean to round. Matthew? Absolute value. You guys remember that now? Absolute value. That's a grouping symbol. You know what else is a grouping symbol? Square brackets. There's lots of other ones that we will see examples of later on, but there's other things that can be grouped together besides just using parentheses. So that's why G is better. G for grouping symbols. The other reason why I like GEMMA better than PEMDAS is, yeah, M stands for not just multiplication, it stands for multiplication and division, but that's the way it's supposed to be. With PEMDAS, sometimes students incorrectly believe that multiplication has to happen before division. Because, do you see how M is listed before the D? And so they think, oh, I have to do the multiplication first, then the division. That's not how it works. Multiplication and division are done at the same time. They just go from left to right. And same thing with addition and subtraction. A stands for not just addition, but addition and subtraction. So that you know addition and subtraction happen at the same time, you just go from left to right. You don't have to do the addition before the subtraction, and students who grew up with PEMDAS sometimes make that mistake. So we're going to practice this today. I want you to start by looking at some of these very short expressions, math sentences that contain numbers and operations. Let's just look at 2 and 3. Before we start simplifying, it is really important that we're listening, so thank you in advance for not working ahead. What do you notice about 2 and 3? Turn and tell your neighbors, what do you notice? And now tell me, what do you notice about 2 and 3? Andrew? Yeah, 3 has parentheses, 2 doesn't. They both have a 50, they both have divide, they both have a 2, they both have a times, they both have a 5. The only difference is this one has parentheses. Is that going to make a difference? Yeah. Okay, so let's go through this. Now, again, I understand that this is not the first time that you have done this. I believe you were first introduced to order of operations in either 3rd or 4th grade. Okay, so I understand that. I understand that you guys feel like you're ready to move at a level that's a lot faster than this, right? But trust me when I say we're going to be looking at things a little bit differently than we have in past, okay? It's going to be more challenging, and the things that we talk about today are going to help us further on in the unit. So I appreciate your patience and your focus. I want you to practice doing your work and showing your work in this way. We're doing order of operations for every problem, so I'm going to start by writing down GEMMA so that I can remember the order that I need to be doing these things. Now, looking at problem number 2, G is for grouping symbols. Do you see any grouping symbols here? No, no grouping symbols. Good. Let's move on. E for exponents. Do you see any exponents or powers? No, no powers. Next one, M is for multiplication and division. Do you see any multiplication or division? Yeah, we see both of them, right? Which one are we supposed to do first? We go in order from left to right. So when I'm going from left to right, what's the first thing I see? Division. So 50 divided by 2. Calculators if you need them, but you should be able to do that in your head. 50 divided by 2 is equal to 25. Okay, are we done with this problem? No, we just did one single step. Notice what we still have. We still have to bring this down. We're bringing down the multiply, and we're bringing down the 5. So that 25 is multiplied by 5. And again, calculators if you need them. 25 times 5 is equal to what, Riley? 125. And so what is this equal to? 125. Notice, this was an expression with a lot of things to do. It was able to be simplified all the way down to just one single number. Okay? Number 3, you already identified this is a very similar type of problem. Let's see how it differs with those parentheses. Once again, I'm writing GEMMA, and you guys have written on your paper too, right? G for grouping symbols. Do you see any grouping symbols? Yes, we do. So listen very carefully. Again, hands down, eyes on the screen. We're not tipping in chairs. We have grouping symbols, yes. Are the grouping symbols themselves doing anything? Is it an actual operation? No. But it is grouping an operation together that we have to do first, right? So the grouping symbols are saying start here. So what should I be doing first? What's inside of them? And 2 times 5 is equal to 10. Am I done? Nope, bring everything else down. Be careful how you bring it down though. Bring it down in the right order. So the 50 is at the beginning of the problem, just like the divide is before that 10, and we're bringing it down in that order. I have students in years past where they do the 10 and then they bring this down after, and that's going to be a very different problem. Okay, so bring it down in the same order that you saw it all. Let's continue on with that order of operations. Any exponents? No. Any multiplication or division? Yes, notice we already did some of that multiplication, right? So in a way it's kind of like I skipped ahead, but why did I do that multiplication early? Thank you for the hands, Caitlin. Because it was part of the grouping symbols, exactly. So now we've done that multiplication. What do we have left? It's actually that division that we have left, right? 50 divided by 10 in your heads or calculators if you absolutely need them. Kale? It is 5. So all of this is equal to 5. Did the grouping symbols make a difference? Yeah, that was a big difference, wasn't it? Okay, let's do the same thing. Please take a look at 4 and 5. What do you notice about 4 and 5? Aaliyah? Yeah, number 4 does not have parentheses. Number 5 does. Again, is that going to make a difference? Find out and see. Working with your groups, I want you to practice modeling it the way that I've shown you, step by step. Take those little baby steps, okay? Step by step, showing your work, writing down Gemma. We're going to pause the recording as students work on 4 and 5. We'll come back together to do them together. All right, students in class have already had a chance to work on these, so let's go over them, including how I want the work to be shown. What's the very first thing I should do? John? Yes, write down Gemma. That way we remember to check the order of operations. Okay, what do I do now, Caitlin? Yeah, no grouping symbols. No exponents. Okay, and pause there. Very good. Do we have multiplication or division? Yes. So what are we going to do? That multiplication. Multiplication has to happen first. Yes, Caitlin. Oh, you were going to say the answer. So understand what this means. Do I always start at the beginning of the problem and read forwards like I do in English? No, we have to kind of skip around sometimes, which means this multiplication, which happens at the end of the problem or is written at the end of the problem, we have to do that first. So what is 9 times 5? Caitlin said that is 45. Multiplication done, but bring everything else down. 30 minus 45. Let's continue on. Took care of the multiplication. Any addition or subtraction? Yep, so what am I going to do to finish this up? Yep, 30 minus 45, and 30 minus 45 is equal to, Andrew, close. Make sure you're careful about the order. This is 30 take away 45, not 45 take away 30. Make sure you pay attention to that order. Do you want to fix it, Andrew, or do you want me to call on someone else? Okay, help him out, Luis. Negative 15. 30 subtract 45 is negative 15. How'd you guys do? Thumbs up, thumb sideways, thumbs down? Okay. So we definitely have some room to grow. Maybe we're ready to listen and not quite work so far ahead, right? Let's look at the next one, number 5. What's my first step? Right, Gemma. And now let's go through that order of operations. Do we have any grouping symbols? Yes. So what am I going to do first? The grouping symbols. What is inside of those grouping symbols? The 30 minus 9. What is 30 minus 9? Emily? 21. Let's continue on. We need to make sure that we remember to bring everything else down. So that parenthesis was multiplied by 5. So that parenthesis simplified to 21 is still going to be multiplied by 5. See how I brought everything else down? I even drew the arrows to show I'm bringing it straight down. And next on the list, E for exponents. Any exponents? No. Any multiplication or division? Yep, we have that one thing left, 21 times 5. 21 times 5 is equal to, Aaliyah, 105. Again, did those parentheses make a difference? Yeah, those are two very different numbers. 6 and 7. What do you notice? 6 and 7, what do you notice? Stephen? Yep. Correct. 6 doesn't have any grouping symbols and 7 does. What's your prediction? Are we going to end up with the exact same answer? Probably not, right? Though, as we've seen in all the other problems, those grouping symbols definitely have an impact. So, order of operations is how we simplify these. So, I write it down so I remember to go in the correct order. Number 6, any grouping symbols? Nope. Number 6, any exponents? Nope. Number 6, any multiplication or division? Actually, no, right? No multiplication or division. Number 6, any addition or subtraction? Yes. In fact, we have both addition and subtraction. So what do we do first? What do we do first? Bladen. We... Okay, but let's go back to the beginning. Up here. I'll wait. Yes, Bladen, A is for addition, but it's not just for addition, it's addition and subtraction. And when we look up here at the description of this mnemonic device, it tells us that we do addition and subtraction from left to right. We don't start with the addition, we go from left to right. So when I'm reading this problem from left to right, what's the first thing that I see? I see the subtraction. So that's why I have to start here, because it's going from left to right when we've made it to just addition and subtraction. And 9 minus 5 simplifies to be 4. Make sure we bring everything else down. So we add 12. I'm not done with the addition and the subtraction. Is there more addition or subtraction? So let's keep going from left to right. 4 plus 12 is equal to 16. Bladen, do you see it now? Okay. So number 7, similar, but this time we have those grouping symbols. So let's go through that process one more time. G for grouping symbols? Yep. So what am I going to do first? What's inside the grouping symbols? You tell me. What is inside the grouping symbols? What does that simplify to be, Riley? What's inside the grouping symbols? Don't go all the way to the end. We're still baby stepping. Yeah, 5 plus 12, which is 17. So the parentheses, those grouping symbols simplify to 17, but we bring everything else down in the right order. So 9 minus the grouping symbols that simplified to 17. 9 minus 17. Any exponents? Nope. Any multiplication or division? Nope. Any addition or subtraction? Okay, listen to me. Why is it that I did the addition first? Because I'm barely getting to addition. Why did I do the addition already? Turn and tell your tables first. Okay, and now tell me, why did I already skip ahead and do some of that addition? Gabriel? Yeah, it was part of the grouping symbol step, right? So I was able to skip ahead to it because it was already part of that grouping symbol. And now we've made it to the end. Any other addition or subtraction? Yep, 9 minus 17. And 9 minus 17 is equal to what cadence? -8. Again, were those different? Yep, those grouping symbols have an impact. Okay, number 8 and 9, same type of thing, right? Group together and not group together. But this is also a good review, absolute value. Absolute value means, do you remember, Orion? What is it?
It means negatives just go into, you take away the negative.
But why? Why does that negative just not matter?
Absolute value, you take away.
What does it mean? Emily. It's not a magic thingy. Good thing we're reviewing before end of year testing, huh? What does absolute value mean? You're writing this on your paper. How far from 0? So why does a negative turn to a positive? Because how far away is negative 17 from 0? It's 17 away from 0. It's not a magical thing, right? It just is asking a question of how far it is from 0. So, number 8. I wrote in my spot where I'd normally write Gemma. Do we have any grouping symbols? Yes, we do. The grouping symbols don't appear as parentheses as they did in the other problems. The grouping symbols this time appear as absolute value. So, up here, when we talked about grouping symbols like parentheses, absolute value, long dividing lines, we're seeing that now. So what should I do first? What is inside of those grouping symbols? What is negative 3 plus 9? You have calculators if your brain isn't quite working, but you can also do that in your head easily. Negative 3 plus 9, John? It is 6, yep. But before, when I simplified what was in the grouping symbol, I could get rid of it. I can't this time because the grouping symbol, have we answered the question of how far away it is yet? No. How far away is 6 from 0? What is the absolute value of 6? It is, Andrew, 6 away. Number 9. This is a little bit different because they're not grouped together. They have their own grouping symbols, right? So what is the absolute value of negative 3? Eyes should be on the screen. What is the absolute value of negative 3? What am I really asking? Turn and talk to your neighbors. There should be way more than 2 hands. And now let's see those hands. What is the absolute value of negative 3? What does it mean? Aaliyah? It's 3 away from 0. How far away is negative 3 from 0? It's 3 away. So the absolute value of negative 3 is 3. Notice, I can't do the addition yet. I can't do the addition because I haven't done the grouping symbols yet, right? So, are there grouping symbols? Yes, I'm working on them. I did the first grouping symbol, bringing everything else down. Oh, look we have a second grouping symbol. What is the absolute value of 9? The absolute value of 9, how far away is 9 from 0, Gabriel? 9 away. There, I took care of both grouping symbols. Any exponents? No. Any multiplication or division? No. Any addition? Yes. Addition or subtraction, I should say. And what do we see? 3 plus 9. 3 plus 9 is equal to 12. All right. Here's the last thing that we're probably going to be able to go over. This right here contains a long dividing line. Do you guys see that long dividing line? We've seen fractions like 6 divided by 2, right? So we know that that line is a dividing line. It's just really long. Fun fact, that long dividing line is called a vinculum. And guess what? It's acting as a grouping symbol. How is it acting as a grouping symbol? Orion? Yeah, it's separating 6 plus 18 from 3, and it's separating it because the 6 plus 18 is grouped together. We need to make sure that we do that first. So let's do that first. Again, order of operations is remembered with GEMA. Are there any grouping symbols? Yes. So what am I supposed to do first? The 6 plus 18. And what is 6 plus 18, Andrew? 24. And bring everything else, instead of down, I'm going across this time, bring everything else over. So we're still dividing by 3. Any exponents? No. Any multiplication or division? Yep. 24 is being divided by 3. 24 divided by 3 is equal to 8. Number 11 is saying this is the same problem, but using parentheses to group instead of a vinculum. Sometimes you will see it like this. This is probably what you saw when you were in elementary school. As you get more and more advanced in mathematics, you're going to see them looking more and more like this, where we stop using parentheses and we use that vinculum more often as our grouping symbol. Let's go through this in the same way. Any grouping symbols? Yeah. It's parentheses this time. So let's do that. 6 plus 18, 24, just like it was before. Any exponents? No. Any multiplication or division? Yeah. Oh, I forgot to bring it down though. Divide by 3. And 24 divided by 3 is equal to 8, just like it was before. But what about number 12? Do we have grouping symbols this time? No. So is it going to be the same? Let's go through it. Any G for grouping symbols? E for exponents? M for multiplication or division? Yes. So what am I going to do first? That multiplication, or in this case, the division. 18 divided by 3 is equal to 6. Bring everything else down. I have not given permission to clean up, so I appreciate you guys being focused on the lesson. 6 plus 6. I've made it through the multiplication and on to addition. And so 6 plus 6 is equal to 12. Your homework: 13, 14, 15, and 16. You don't need to do any more than that, but you do need to do 13 through 16 for homework. That's it for today's lesson. Thanks for watching. We'll see you next time.